I've been doing some reading, studying online. I've learned some very interesting things, one of which is there has been apparently a replication of William Lyne's experiment in which he put 2 watt-hour meters that were very old, they were like a century old, more than a century old, into his apartment building back in the late 60s or late 70s to measure power in that particular apartment unit. And he claims he wired them backwards, and that's what created the power gain when the load was sufficiently high enough that he ended up with an over-unity situation, and he had a balance of load in which the 2 units snored like crazy, vibrated the entire building, when the load was reduced somewhat. And the power consumption on those meters merely slowed down when his power usage was still lower. Well, apparently, and studying the matter, getting the electrician's handbook, the Meterman's handbook from 1912, you can also get PDF version online. It talks about power factors, and if you get a 60-degree difference between the current aspect of the AC current versus the voltage, then you have a condition that, I forget what they call it, but it sounded equivalent to what William Lyne was describing, a balance of load. Well, I don't know how to regulate that power factor, to monkey with it. Well, apparently people online have managed to focus just on that. They set up a motor and a generator, and it's a closed-loop system that's self-running because they monkey. It's an AC power motor and an AC power generator, and they get it to work because they monkey with the power factor, the current phase relation versus the phase relation of the voltage. Which one leads, which one follows, how much difference between them per cycle. So now if we take this and apply it to a DC setup, you would think, well, how would that be applicable? It is applicable. Even though an AC transformer, we don't normally think of it in DC terms, yet Edward Leeds-Skolnin's perpetual motion holder is a snapshot of an AC transformer in operation, because even though it's DC, that's what AC transformers do. You load them with energy and you discharge them of their energy. And that single cycle of charge and discharge is literally what Edward Leeds-Skolnin's perpetual motion holder manages to do. So at the heart of an AC transformer is a DC process of inductive charge and inductive discharge. Well, in this situation of a unipolar or homopolar Faraday disk, we got a similar situation. We can apply certain AC concepts, and one of it has to do with the power factor. Normally you wouldn't think of that having to do with DC current, yet we know from Tesla's deposition, or testimonial I should say, when he had the lineman first turn on the power generator at Niagara Falls hydroelectric power plant that he had set up to send the power to the city nearby, they had to get the RPM of the generators up first, and then they switched on the connection between the generators at the source, them, and the power consumers in the city. Well, a voltage spike leaped across the switch, coming out of the switch, killing the lineman, and they had to shut the whole thing down and figure out how to, put in a safety catch. But in the meantime, he studied it and he learned about radiant energy from those voltage spikes. Well, monkeying, that shows that the voltage got ahead of the current. The voltage leaped ahead, and the circuit was not designed to carry that much of a voltage surge. So it had nowhere to go but to leave the circuit and look for ground elsewhere through the body of the lineman into the earth. So what we can look at then is the description that Alan Trombly shared with Brian Strom, that when Adam's unit, and it was a solid state unit, was operating at peak, no, it wasn't. The solid state was a different model. No, it was the mechanical version, the standard unipolar, well, modified by Adam Trombly. So when he had it running efficiently, the the copper disc was saturated with current. And that tells me that there's already an imbalance between the current aspect versus the voltage. And of course, unipolar and homopolar discs tend to have low voltage and high current as it is. Now, Adam said to Brian, the casement, the case around it is significant, and Brian couldn't figure out why the case would be significant, but William Line made it very clear to me in email correspondence that the case is significant. It has to be an iron casing. What's added to that situation, of course, is that the iron casing has to be magnetically coupled to a larger mass of iron held elsewhere to divert, even if it's only a small amount of the magnetic field that iron casing picks up to an area far away from the device, or just simply away, to dissipate it, to act as a sink, a magnetic sink. And that's creating a power factor alteration to the DC current, in which the current is going to be more amenable to saturating the wires that it goes through, as opposed to if you didn't do that. So here's again confirmation of the importance of a magnetic ground, a sinkhole, a magnetic sink, just like a heat sink. It's really, in fact, I remember that heat sinks work the same way as a magnetic sink in terms of geometry. So there are ferrofluid videos on YouTube, and they use a pillar with ridges spiraling around it, or grooves, I should say, grooves and ridges spiraling around it going up to the tip. And they set it in a pan of ferrofluid, and they put the magnet underneath. And very slowly they increase the magnetic strength, I guess it's an electromagnet, sending the ferrofluid up the shaft higher and higher, defying gravity, but it travels along the ridges, not the interior space between the ridges that are spiraling around that spire, sticking straight up. So that tells me that magnetism is strongest at the ridge and practically non-existent in the curved or the ridge spaces in between the edges. I'm sorry, in the spaces in between, the valleys in between the ridges. There's no magnetic field coming out. It all comes out off of the edges of the ridges, spiraling up. So this tells me, just like a heat sink, you put fins on it, on the exterior to carry the heat away. Well, we think it's because we want to increase surface area, but in this case, it's slightly different geometry, the way the magnetic field works, but it's the same geometry of the sink that you use. Namely, you've got fins pointing away from your sink area, the source that you want to deplete of heat, in the case of a heat sink, but you have surface areas, flat surface areas, surrounding the source of your heat. Well, in the case of magnetically carrying the magnetic field away from a magnetic source, you have the same geometry. And for all intents and purposes, it may be even made out of the same material as a heat sink. I don't know what heat sinks are made out of, if they're made out of iron or copper or iron or bronze or aluminum. If they're made out of iron, then you can just use a heat sink, if you've got it handy. But it would be, for starters, it would at least, help in a small way. Although Tesla said the amount of iron you have to use is humongous, 200 pounds apiece per horsepower output increase of his device. So it sounds like we're dealing with the same thing with DC current as we do with AC current. We're creating a phase relation offset between the current aspect of DC and the voltage aspect, even though theoretically there's not supposed to be a difference. But of course, everything about conventional electrical theory we know is not complete. It's not false, it's just not complete. And that's something else I read today. What was the guy's name? He was an Englishman who came after Maxwell, who put all the equations together and published them. Clerk Maxwell had these various equations, and it starts with the letter H, the last name of the guy, the Englishman. because Maxwell died young, and this guy came in and put all this stuff together and published it. Well, he published two sets of equations. One set had to do with symmetrical situations, which are closed-loop situations. The other set of equations had to do with asymmetrical open systems. And when the power brokers over 100 years ago, about 130, came on the scene, they obliterated, or even before 130 years ago, they obliterated the asymmetrical, they obliterated our social awareness of those asymmetrical equations, so that we're only taught the symmetrical ones, which are valid for symmetrical systems. So we've been lied to by not being told the whole truth. We've been given half of the math behind electrical theory. The other half is missing, namely asymmetry. And we have to have people like Eric Dollard to reinvent the equations having to do with asymmetry, or just electrical theory to be able to handle asymmetry, for that matter. Just electrical theory in general, to be able to handle both symmetry and asymmetry in a coordinated fashion. And that's what Eric Dollard has managed to do. So it's been a very interesting morning, crash speed reading and crash course studying these various things. I learned about other things I'm not going to get into because I want to stay focused here, but this is very interesting, and it means that it's just one more validation of just one aspect of William Lyne's story, the need to magnetically sink, or carry away, I should say, the magnetic field generated by the device. Now, there's one other point to raise, and that is I ran across a patent that serves as the foundation for current day, oh God, now I forgot the name of the motor. It starts with an R. Is it RUT? Ooh, darn it, I forget the name of the motor, or generator. It's a specific type of generator motor. And Tesla's version, he made a patent, and it was 1894, and the name of the patent is simply electric generator, a very simple name. And it's a reciprocating generator, powered by compressed air, with air springs to allow the reciprocating piston action to have a spring action both ways. And it drives a shaft reciprocating some magnets that have a linear relation inside a larger horseshoe magnet with coils on it. So it's an AC generator, basically. So I found that highly intriguing, and I'm going to have to study it some more to see whether or not it has any relationship to his further development that we don't have access to, and that's his special generator, which would have been an offshoot of this one. So you just combine, I guess, this one with the other. Well, no, you wouldn't need the bladeless turbine, and you would not need the one-way flow valve. In fact, he said in the patent, you don't want a valve obstructing the exit of the air. You want it to vacate very quickly. Just the opposite of what I've been supposing. In fact, there's several things in my line of reasoning in my past videos that are the opposite of what they should be. And I'm not surprised. Usually when I try to follow logic in an area that I have no background in, I usually make the mistake of considering the opposite is true when in fact it's false. And it's just a flip of orientation of a bipolar system. But, you know, that's uneducated logic for you. I tend to get everything backwards. So my battery is telling me I'm low. I'm going to have to stop the video recording. Reluctance motor, or reluctance generator. I guess my memory bank was reluctant to remind me what the word was. That's the term of the current day rotary generators and motors that are predicated, apparently, allegedly, off of Tesla's patent of his electric generator from 1894. But some people are saying it's a scam because they try to teach you how to build your own. Maybe that's the only right way to go about it rather than building one themselves. Regardless, at least it helps me reading his patent, and they did cite his patent. Reading his patent at least motivates me to consider that that may be the basis of his special generator, because it's got a reciprocating piston run by compressed air. So we add in the patent he never got to patent because his lab was burned down, and no sooner than it was burned down than some guy by the name of Linde, Linde, in Germany patented the liquefaction of air process that he was going to patent. So that made the storage of compressed air on board the Electro U-boats outfitted with electric drive and his special generator possible. So I'm just going to attack it from that standpoint, try to assemble it using what we know, and that seems to be the only way to plod my way forward, baby step by baby step, still just on the basis of theory, because the design characteristics, I got to go theory first before I can even begin to build anything, because I've got to make sure that it makes sense. And I'm sure it's a simple enough procedure that would make sense. So I've done the experimentation with a very long piece of iron wire and a neomagnet and a compass to know that magnetic waveguides or shielding made out of shaped magnetizable material is a very real prospect of reshaping your magnetic field so that most of it is somewhere else away from the device, based on how much of the mass of iron is surrounding your device and how much of it is elsewhere away from the device but magnetically coupled to the device. So if you've got 99% of your iron elsewhere, far away removed from your device, and only 1% surrounding your device, and the two magnetically coupled, then you've got 1% of your magnetic field generated by your, or 1% of the field that's being soaked up by the iron in the vicinity of the device, while the other 99% soaked up by the iron is elsewhere. The other interesting thing worth mentioning, I learned from, what's his name? Geoffrey S. Miller. He's in Pennsylvania. He must be the reincarnation of Tesla. Be that as it may, he discovered that rather than using a solid iron core, it's more efficient to use an iron pipe as your core material within your coil of wire. And to reduce eddy currents, he puts a slot, a lengthwise slot, down the length of that pipe, so it's not a solid pipe. But apparently the thinner the pipe you make it, the better the results are. And that's because a solid iron mass will saturate with magnetic field and hold on to it, while a honeycombed or hollow iron mass will more readily give it up. So it allows for switching. It allows for rapid switching. And this means that the hull of an electro U-boat, or a hull of a U-boat for that matter, is not a bad idea because it's not a solid iron mass in its entirety. We've got an iron hull, that's the shell, but then we've got all these iron supporting structures on the inside to maintain the integrity, the structural integrity of that hull. And then we've got walls, floors, doorways, all kinds of fabric that's honeycombing the system with more iron, breaking it up so that it's not all one solid mass. So what that means is, if we do something similar to what we do when we create colloidal silver, namely, when the black silver comes off the shiny metal-looking silver electrodes, what we're doing is we're not creating silver sulfide, as some claim. There's not enough sulfur in the distilled water, or in the dissolved gases, for that matter, in the distilled water, to give silver sulfide deposition on the in the water or on the electrodes. That's etching that creates that darkening. That means the silver etching is porous and allows for my hydrogen peroxide reaction against that to be very efficient when I make silver hydroperoxide for my bath, along with the ingredients of MSM and salt. So that kind of etched process of etching metal and creating a sludge, if you run this colloidal silver generator long enough, you end up with sludge at the bottom, or suspended for that matter, in the water if you keep it stirred. And it's solid mud. I mean, you literally can, if you run it long enough, you can get solid mud out of it. But the important thing is to keep it in a state in which the metal particles are porous. And if that can be solidified, in fact, now that I think of it, it doesn't have to be porous with air. It could be porous with some other material to suspend it. Epoxy, ceramic, plaster of Paris, something rubber. In fact, Brian Strom used little rubber balls impregnated with silver as his contacts of choice between his alternating counter-rotating unipolar discs on his unipolar generator. So there must be a source of rubber balls or styrofoam balls that's embedded with iron filings. You know, something that would give you the iron, but the iron is spaced out so that you don't have one solid mass of iron. That apparently is what the foundation is of using an iron pipe with a slit down one side instead of a solid iron core to a coil of wire. So the question arises, well, do you need then to take iron filings as a paste and paint it onto the inside of your hollow core of your coil of wire, and just leave, and then, you know, put down a painter's tape strip very thin down the length of the inside of that hollow core of the coil of wire. Let's say it's a plastic core, and then you can rip it off to expose the bare area. Or you could use shellac mixed with iron filings. That's even better. Natural shellac. Or as Tesla would do, 50%, or 1 part beeswax, 1 part pine rosin, and 5% carnauba wax. I mean, as your sealing resin, instead of sealing your coil on the outside with, or in addition to sealing the outside of the coil of wire, you use it on the inside, but you've got iron filings, in a soup of iron filings mixed in, and then you've got to strip down one side that you had blocked off with painter's tape and that you can remove. It could be paraffin wax with the iron filings mixed into it, or beeswax for that matter, the mixture. So paraffin wax isn't as good. I've used shellac, and it's much better in terms of at least attracting the ether. Whether or not that has any effect on the circuit, would remain to be seen. But for ether circuits such as orgone wrapping, it's excellent using natural shellac versus paraffin wax is a waste of time. So that would be an idea to make the iron even thinner than an iron pipe and still have the slot down one side. But that's how to do coil of wire efficiently, according to Geoffrey, Geoffrey, middle initial S as in Samuel, Miller. And he's out of Philadelphia? Or, somewhere in Pennsylvania. Let's leave it at that. I can't remember. It might be Philadelphia. I think his website is Electrobat or Electrolab. Oh God, now I can't remember the name of his website. He's on Penn's Wiki. He's talked about, so you could Google him, and he's there on the internet. It's quite interesting. He's replicated so many people's work. Tesla, Bedini, Newman. Oh my God, the list is so long, and he's replicated so many people successfully. It's quite a phenomenal genius. This guy's like in his mid-50s or late 50s. Mid-50s, that's right. And he said his breakthrough came last year when he replicated the Newman motor with improvements so well that Joseph Newman gave him a licensing to build Newman motors on his own. So the guy is quite a genius, quite a source of information. There's no question about that. I'm sorry, is that PESWiki instead of PENSWiki? PES instead of PENS? No, I can't remember. My memory sometimes.